right, question number 9 is, why is PEP a higher energy phosphate compound than ATP? All right, well, first of all, it has some of the same energetic stabilization as ATPs. So in PEP, we have a negative charge carboxylate and a negative charge phosphate. So both those charges want to repel each other. So we have electrostatic repulsion. We also have competition for the resonance electrons there. All right, so those resonance electrons, they're competing resonance forms. They're basically pulling them in two different directions. Once we hydrolyze PEP, those electrons are no longer being competed for, because now both the products have their own lone pairs of electrons and own independent resonance forms. And thirdly, it's fairly hard to solvate the phosphate and that hydroxyl group that's bound to the phosphate in the intact PEP molecule. But once we hydrolyze PEP, now we have a free phosphate and a free pyruvate, and it's a lot easier for water to enter into that interface there and create more hydrogen bonds with our products than we had with our reactant. So those are reasons why PEP has at least the same amount of energy as ATP. Now, why is it a higher energy phosphate compound? Well, that's because once we cleave off the phosphate from PEP, we create an enol, where we basically have an alkene that is directly bound to an alcohol. All right, now enols are inherently unstable. The keto form is much, much more stable. So that alcohol, the lone pairs of electrons in the alcohol are going to tend to collapse back down, forming a ketone, which is then going to force that alkene to get protonated and become a carbon-carbon single bond. Right? And so that equilibrium lies very, very strongly towards the keto form. So as soon as we hydrolyze PEP, a second reaction occurs, which is the tautomerization of that enol form to the keto form. And we end up adding those two energies together. So we start off with an energy that's already pretty similar to ATP, add to it another irreversible reaction. So another reaction that has a strongly negative delta G. And this explains now why PEP is such a high energy phosphate compound.